Today we are talking about Phoenix LiveView custom components, what they are and why they matter. In LiveView, function components let you extract reusable UI into isolated composable units. The goal is simple: reduce duplication, improve readability, and keep templates maintainable. Right now, we have a problem. Our card layout in home_live.tx and show.tx is almost identical. We are repeating ourselves, and that's exactly what components are meant to solve. So let's fix it. First, I create a new folder inside components called blocks. This will group all blog-related UI, cards, grids, pagination, search. Inside that folder, I create blog_grid.tx. We define a module, def module, phxblogweb.blogs.bloggrid, and bring in HTML helpers with use phxblogweb HTML. Now we create component blog_grid. We paste our created blog layout, and inside we loop over blocks. Each item can come in two formats, either DOM ID and blog or just a blog. So we normalize it using a private normalize function. This guarantees every item has consistent DOM ID. Each block is rendered as a card, image at the top, title wrapped in a live view link for navigation, truncated, content preview. Everything is self-contained and reusable. Last but not least, we define attributes. Blocks required, this is our data source, ID optional, defaults to blocks for DOM targeting. We use attributes because it defines the inputs, props of a live view component. Enforce required data, provide defaults, get compile time validation, make the component predictable and reusable. In short, it's the component's contract. Now we use it. In home_live.tx, we import the component and replace duplicated markup with blog_grid. Quick check, and everything works. Next, we do the same in show.tx inside the featured block section. Import, replace, done. Again, works exactly as expected. Now we take it one step further. Instead of keeping layout logic inside show.tx, we extract a new component, featured blocks. Same approach, create file, compose it using blog_grid, keep show.tx clean and focused. Import it, replace the old code, test, and it works. At this point, the pattern is clear. Now you can continue extracting reusable pieces: block card, loading state, empty state, and error state. The idea is to separate concerns and standardize UI behavior across the app. Next, we will go deeper into live components for stateful interactive reuse. So, see you there. Now we move to live components in Phoenix LiveView. A live component is a stateful reusable UI unit. Unlike function components, it can manage its own state, handle events, and communicate cleanly with its parent LiveView. You use it when the UI becomes interactive and you want to isolate that behavior. Search is a perfect example. So let's implement a proper search. I start in a blocks.ex inside the context layer and define filter blocks function. The flow is simple. I begin with the block query, pipe into search by, apply constant ordering so the most recently updated and created records come first, and then execute the query with repo.all. The key part is search by, where the query becomes dynamic. I use ILive to match against both the title and the content. If the query param q is empty or nil, I return the query unchanged. If q is present, I extend the query with a where clause. This keeps the logic clean, composable, and fully handled at the database level. Next, I move to the UI layer. Inside components/blocks, I create search_live.tx and define a live component using use phxblogweb live_component. This gives me lifecycle, state, and event handling. Then I implement update function, which is the entry point for assigns. I assign incoming data to the socket. Use assign_new to guarantee defaults like navigate to and placeholder, and return the updated socket. This ensures the component is safe to reuse in different contexts. Now I handle interaction in handle event function. I listen for the search event, extract the query queue, and send a message to the parent live view using search and queue. I'm not mutating state here, I'm delegating control to the parent. That separation keeps things predictable and easier to maintain. Next, I define the component API using attributes. The form is required and holds the form state, while navigate to and placeholder are optional and give flexibility for routing and UI. Now I integrate everything into home_live.tx. I create handle params, which reacts to URL changes. I extract queue from params called filter_blocks. rebuild the form state, and stream the updated blocks. At this point, the URL becomes the single source of truth, which means no hidden state and no inconsistencies. Then I implement handle_info function to handle messages coming from the live component. I receive search and queue, build the query params, and call pushpatch to update the URL. That triggers handle params again, and the UI updates automatically. The flow is simple and consistent. Event, URL update, state update, re-render. Finally, I render the component by providing the module, setting a stable ID, and passing the form state. Let's test it. And now it works exactly as expected. At this point, we have isolated search logic, URL-driven state management, a reusable live component, and a much cleaner live view. Next, we will build on top of this and implement pagination. Now, as promised, let's implement pagination. Pagination is simply the process of splitting large datasets into smaller chunks or pages. We need it to avoid loading everything at once, improve performance, and keep the UI responsive and scalable. Before we start, I will introduce a lightweight hex package, PageX Pagination. We are going to integrate it into our project instead of building pagination from scratch. Setup is straightforward. I go to the package page on Hex, copy the latest version, and add it to mix.exs. Stop the server and run mixdeps.get. That pulls the dependency into the project. Next, I move to blocks.ex. I alias pagex and update filter blocks function. Instead of calling report at all, I delegate execution to pagex.paginate. I pass in the query params and the repo. At this point, the function no longer returns just a list. It returns a tuple, the paginated records and metadata. That metadata includes things like current page, total pages, and navigation info. Now I create a new live component, pagination_live.ex. Same pattern as before. Inside update, I assign incoming data to the socket and define defaults using assign_new. Base path defaults to /, queue defaults to an empty string. This ensures the component works even if optional values are not provided. Next, I implement build params. This function builds the query string for pagination links. If queue is empty or nil, I only include the page parameter. If queue is present, I include both page and queue. Then I encode everything using URI.encode_query. This ensures pagination preserves the current search state. Now I move to home_live.ex. First, I handle the page param. From the params map, I try to fetch the value under the key page. If the key exists, I use its value. If doesn't exist, I fall back to 1 as the default page. When I call filter blocks, passing the query page and page size, the function returns two values, the list of blocks and pagination metadata. I pattern match them into blocks and meta. Now I'm receiving both the data and the pagination metadata. At the top of the module, I define module attribute called page_size and set it to 9. This controls how many items we show per page. You can tune this based on your UI and performance needs. Back in the live view, I assign meta to the socket. This will drive the pagination UI. Finally, in the template, I render the pagination live component. I pass the metadata, base path, and current query. Now let's test it. And everything works great. At this point, we have added efficient data loading, consistent URL-driven pagination, reusable pagination component, and preserved search state across pages.